Hi, everybody. My topic is reverse engineering of application, what you can get from it, but I guess you were clickbaited because in reality, the second title, I prefer more how to get into the macOS release notes because I won't be talking about much of techniques of reverse engineering. I will focus on the software engineering part, what we as software engineers, because I'm a software engineer, what we can do to protect our apps, and what will happen if somebody tried to exploit our applications. So, as it mentioned before, my name is Roman. I'm software engineer at CleanMyMac team, and also I'm lecturer at Kyiv School of Economics. And first of all, why I'm here while talking to you, while I'll be discussing some points with you, because a lot of applications have security flaws, even if these applications are already on market for some time. Even if this application uses some bug bounty programs, they still can be vulnerable for attackers. So that's why I'm here talking with you, because we need to improve that. We, as engineers and researchers, need to improve security. And specifically what I will be talking about is I'd like to address and ease how we can exploit some applications and how we can get information from this application. So I have a question for you. I do not like when people talk some presentation and I'm only one who talking, so I have a question for you all. So how do you think, how hard is to get information from application? So we have some binary, so how hard is it? Depends, okay. Easy, well, it's very easy. Actually, it's very easy because majority of engineers did not think about, okay, I shipped my application, well, now it's customer problem, so I do not need to care about it. But in reality, you do need to care about it because when you program your application, a lot of information you can expose actually can be used by attackers. So yeah, and that's actually one thing that attacker can do with poorly secured applications. Yes, they can exploit some underlying vulnerabilities. They can get some information. For example, they can get some private information about our company or about our customers. So they just exploit our application to get this information and further to attack or our company or our customers. So that's one thing they can do. The second, well, how they can do, yeah, they can debug our application. They can disassemble it, they can look onto it, find some hard-coded keys that should not be hard-coded in your code, yeah. The best practice of all engineers, take your key and just put it in your code directly. So yeah, they can find some API keys, some database credentials, and so on and so on. And the third thing, it's case studies. It's why we're all here today. We gathered to case study some real examples from security world, from the world of application building. So that's what we're doing today. And let's look at example, because I'd like to show you some example about and discuss it later as a practice. So I have virtual machine running right on my Mac right now. So, and it has installed some application that I built. It's called the good project. So I want to bring some good to my people, to people. And I'm also playing the role of attacker. Yeah. So I created some script on Python. And I want to execute it. So you see, we have a good project app in directory and exploit by that is my script that will invoke the thing I want to do. So and it will launch. It will do something. I hope it should work. So I guess I need to give me a second. I'll try it again. Yeah, exploit successfully. So what my exploit py scripts do, yeah? It's start exploit, it set up some environment, and after it set up some environment, it tries to launch my good application. I try to exploit this application, try to get something from it. I'll wait for some time to my exploit finish and print exploit successfully. What I get from this exploit, yeah? We can check it. So my script get address book, cookies, and desktop files. It just copy it to some directory. Well, in reality, it would be some API call, and all this file will go somewhere to the internet. Yeah. So what happened here actually? Yeah. So let's try to think what happened here. Our malicious script that we launched was able to mimic for our application. Yeah, it was able to bypass the macOS TCP security, and the macOS thought, okay, is this app running? It has permission to. Sorry, macOS thinks that our application has permission to address book, cookies, and desktop files, and it allows our script to get these files. Okay, so we like tricked macOS into thinking that our malicious script is actually an application that has this permission. So how this can happen actually? Because it shouldn't happen by itself. So there should be something. Let's try to deep dive onto our application and look onto it from the hopper. I guess you already seen the hopper today, and you can like navigate there. Yeah. So let's try to find something that's interesting for us. And I already highlighted the line of code that we need to look at. It's this one. So we see that our application at some point of time use varis binary. Yeah? And varis binary, it's a system binary that exists in the system, in each macOS have it. And this binary is designed to define the binaries, the past binaries. Yeah? And our application uses. And since we are good software engineers, and we're good, yeah, we tried to we wrote the whole path. Yeah, we wrote that this binary is located under the user bin varis. So we're safe here. So that's a good sign. But somehow we still have this problem. Yeah, somehow our scripts still access this information through our application. Yeah, and you can see it from different perspectives. Like, don't think much about it. So let's dive into the varis binary. So varis binary, it has a lot of code underneath, but like if you look into it, you'll notice that at some point of time, varis also uses another binary called MacPaw. So MacPaw is another system binary that invokes some code and bring and do something. And luckily for us, MacPaw is not binary actually, it's a list of functions. And if we try to look at the functions, we'll find this piece of code, and this piece of code contains vulnerabilities that we exploited at the beginning when we started our script. And if you are, I think you can already see it. Yeah, we have it here, right here. So actually, the vulnerability lies in this xcode select invocation. So basically, we have this function xcode pass. We're trying to find the path to our xcode, and then in xManPass variable, we're trying to write result of executing command xcode select show manpass. And what's happened here? We actually changed the xcode select. Yeah. So we changed it to our own Xcode select, and then we launched our application with this changed Xcode select. Yeah, and we can check it by exploiting the vulnerability itself, so we can understand that firstly, okay, it was good project app that it was launched, then good project application invoked the Veris invoked MenPass at some point of time invoked Xcode select. And as you can see, this Xcode select is located not in the system folder. Yeah? It's located somewhere else in the folder named TMP that we created by our script. So we actually changed the system Xcode select to our Xcode select. So how we did it? Yeah, we created this binary. So we created that folder TMP Xcode select. We write some comments to it. This is some part of these comments. So for example, we created some folder TCC bypass exploit. We created process tree info to understand where problem exactly is. And we wrote some function and wrote these 3 lines of code. So these 3 lines of code with copy recursively our cookies, our application support address book, and copy desktop to our folder, to our non-protected by the system folder that we can later on send to the server or whatever we want to do with it. And the actual exploit part is right here. So we just decided to set env pass, and we changed, by this, we changed Xcode select that our application will invoke. So the path is next. We have a good project app. It invokes one binary, whereas then it invokes the second binary, MenPass. Then it tries to invoke the Xcode select, and we change this Xcode select. Now it's our malicious script. So this chain of binaries. So the most terrifying part of this exploit, it's not only about the fact that we got all permissions of applications that utilizes some system binaries. The most terrifying part, in my opinion, was that if we try to do something in our script that application does not have permission, the system will try to will invoke the system dialog that good project app tries to access, for example, your contacts. And this part is more about the social engineering, because you okay, do I trust this application, my contacts or not? Do I need to share my contacts or not? For example, if I trust this developer, well, maybe they needed some for reason, yeah, or no? So yeah, it will try to access new permissions, and it will invoke and copy all the files. It will do whatever it wants with our application and steal data from our users. So when I found this vulnerability, of course, I prepared all the necessary information, like I listed here, for the Apple, and I've sent it to him. I described the possible attack vectors. For example, there would be a bunch of applications that utilizes different binaries among them that were in this chain. So, and I sent it to him. And then after the 6 months, roughly, because we spoke from time to time, they responded with some confirmations, or they needed additional information about that. They fixed it in a new macOS update. So, and now if you try to check the MenPass binary, or not binary, it will look like something like this. So you see, they wrote the whole path for the Xcode select, and then they tried to invoke it. So what do you think, how difficult it is to, well, because in my opinion, this kind of vulnerabilities is not very hard to detect. It's not very, you don't need any additional information. You don't need to debug. You don't need to launch your application. You don't need to change certificates of some application. You just like connect, set env, and you are in the system. Yeah. Yeah, about the bounty, because Apple have the bounty program, so bounty is still in reviewing. It's been like more than a year, so we're still in the reviewing process. I guess at some point of time I will update. Well, if not, then not. Oh yeah, and they published the release notes with acknowledgement, as they usually do. So the main point of my presentation was be careful when you use system binaries, and do not trust even the system when you are developing your applications, because sometimes it can lead to loss of data and to vulnerabilities, even though you didn't intend it at all. So I guess that's all from my part. Thanks for you.
Thank you, Roman. Do you have any questions? Sorry, I see you now.
Hi, thanks
Hello.
for the presentation. I have a question. Was it discovered before launch constraints feature or after?
Can you remind me, please, about launch constraints?
It's a feature when you cannot launch system binaries from their original path. For example, if you copy it to some other path.
So in this particular case, the Xcode select that I launched was not like a system binary. It was like chmod X, an executable that I created. I'm not sure if this particular fix is connected with this new feature you described. They fixed it about a year ago with Ventura 13 something update. I'm not sure, like if it was before or after this.
I'm asking because the fix, they just hard-coded full path.
Yeah.
And launch constraints kill a class of vulnerabilities when you remount system path and place there your own binary with the same name.
Mm-hmm.
So in case when you search for this system binary, your remounted path first in the search path and then executed your binary.
Okay. So
I guess that's the question.
Yeah. Okay. I guess in this case, this type of vulnerabilities will cease to exist.